This video is about route inspection. Sometimes you'll see this referred to as the Chinese postman problem, which is not a lovely name, but you may see that referred to in other videos. But anyway, it's route inspection. We've got a network of railway tracks here, and they need to be inspected. These numbers are the length in kilometres of each of the tracks. Each track must be traversed, you must go along, the inspectors must go along each track at least once, but obviously the length of the inspection route should be as small as possible, and the inspection route should start and finish at the same point, at the same vertex. So we need to find the length of the shortest inspection route and make your method and working clear. So we need to go around every route here and make the whole journey as short as possible. Now there is an algorithm, a route inspection algorithm that we need to use, and the first thing is to identify the vertices, the points, the letters, where there's an odd number of tracks coming out of them. Now the number of tracks coming out of each point is called the valency. So if we think about the vertices here, then the valency of A is 4. That's because there's 4 tracks coming out of A. 1, 2, 3, 4. The valency of B is also 4. The valency of C is 5, and so on. So I've made a deliberate mistake here. It may be worth pausing the video to see if you can work out which of these numbers is incorrect. And the answer is that it's G. That should be 5. So what we need to do to start using the route inspection algorithm is to identify the nodes which have an odd valency. So they are C, E, C, D, E and G. And we'll need to do some further work on the next slide. So we know that the odd vertices, get the words out, the odd vertices are C, D, E and G. And what's going to happen is that the routes between the odd vertices are the ones that are going to be repeated. So that's so important, I'll say it again. The routes between the odd vertices are the ones that are going to be repeated. So what routes exist between these odd vertices? Well, it could be CD and it could and EG, or it could be CE and DG, or it could be CG and DE. Now, in an example outside of a Maths A level, there could be a huge number of these, but the normal thing, it's not guaranteed to be like this, but the normal thing in these questions is that there's 4 vertices, we've got to consider 3 routes. So what is the shortest route from C to D? There's 2 ways of going from C to D. There's C, there's D, it's either 17 or it's 25, 12 and 13 is 25, so consider the shortest route, that's 17. And E to G, the shortest route from E to G is 19. So the total route, if we're going to repeat this and we want to minimise the routes that are repeated, is going to be 36. What about CE? Have a think about it before I write it in. Is it going to be 12, that route, or is it going to be 17 and 13? Well, obviously it's going to be 12. But don't be fooled, it's not always the one that appears to be the most obvious. From D to G is going to be the 25 that's there. So 12 plus 25 is 37. So if we repeat CE and DG, then that's going to be 37. That's longer than the 36. But maybe CG and DE is going to be repeated. From C to G, the shortest route is 28, and from D to E, the shortest route is 13, which is 41. Now this working here gets marked. If you don't put in this working here, you're losing method marks. So the shortest route to be repeated is going to be CD plus EG. Now CD plus EG is 36. the total length of all the railway tracks is 543, there it is. So 543 is going to be the total length, but we're going to repeat CD and EG 36, so the shortest route is 543 plus 36, which is 579 kilometres. Make sure you put the units in. They do sometimes give a mark, or take a mark off if you don't put the units in. So it's 579 kilometres. Now in part B, it's permitted to start and finish the inspection at 2 different vertices. So you need to state which vertices should be chosen to minimise the length. Now if we go back to the previous slide, you can see that the shortest of all those routes is CE, which is 12. There we are, I've written them out again for you, and you can see that of these numbers, just looking at these numbers here, the smallest number there is 12. So that's the one that we're going to repeat. We're going to repeat CE. So repeat CE. So we're going to go along CE twice, which means that the other part of that combination, that part there, is the start and the finish. So let's just answer the question. It says, which 2 vertices should be chosen to minimise the length of the new route? So we can, so this in black, here we go, we can start and finish at D and G. It doesn't matter which way around we do that. Have we given a reason yet? Not really. We've said repeat CE because CE is the shortest. And let's just put a 12 in brackets there to show that we've done that. And that's route inspection.